Hello everyone. Welcome back to the AWS Certified AI Practitioner Certification Bootcamp. In this module, we are covering some core AI/ML model evaluation concepts. According to the AWS Certification Guide, you are expected to understand model performance metrics like accuracy, area under the curve, and F1 score, as well as business metrics like cost per user, ROI, and customer feedback to evaluate ML models. We will cover all these concepts and metrics in this module. By end of this module, you will have a complete understanding on the core ML model evaluation concepts. Before we cover the evaluation concepts, we will cover the concepts and algorithms used in binary classification. Then we will review performance metrics like confusion metrics, accuracy, area under the receiver operating characteristic curve or AUC-ROC, F1 score, then regression metrics like mean absolute error, mean absolute percentage error, root mean squared error and R squared, as well as the available business metrics. And as a bonus, before concluding this module, we will discuss the machine learning anti-patterns. That means for what are the use cases you should not use machine learning. The certification exam will have at least one question to test your knowledge on when you should not use machine learning model to solve a real world problem. If you review this video without skipping any content, you should be able to confidently answer 3 to 4 questions related to model evaluation metrics and machine learning anti-pattern. We have a lot to cover. Let's dive in. Let's start with binary classification. In binary classification, the model predicts one of the two possible outcomes. It answers questions like if the email is spam or not, will the customer churn or stay, is the transaction fraudulent or legitimate. These problems are called binary because there are only two cases or two outputs. Either it could be yes or no, or true or false, or 1 or 0. Binary classification is used in a wide range of applications, including medical diagnoses, to identify diseases like if a tumor is benign or malignant. Also to detect spam email, that means filtering unwanted emails. Also for fraud detection. For financial institutions to identify a transaction is legitimate or fraud. Various algorithms can be used for binary classifications, and common algorithms like logistic regression, decision tree, support vector mechanism or SVM, and neural network. For this certification exam, please remember the use cases or identify the use cases where outcome could be 0 or 1 or true or false or positive or negative, and the common algorithms you should use for binary classification. Now let's move to confusion matrix. A confusion matrix is a visualization tool used to evaluate the performance of a classification model in machine learning. It summarizes the results of predictions by comparing them against the actual or true values. Confusion matrix is represented in a tabular format, and the table shows the number of correct and incorrect predictions for each classes. The actual values are represented in rows and the predicted values by the algorithms are represented as column. If we take an example where our machine learning algorithm is trying to detect an email is spam or not, then for a 2 by 2 confusion matrix, there could be 4 possible values. First one is true positive. That means instances where the actual email is spam and the machine learning algorithm also detected that email as spam. That means the prediction matches the actual value. That is called true positive. Then false negative, where the actual email is spam, however the model predicted it as not a spam. That means these are the missed cases. The next is false positive, where the actual email is not a spam, but the model predicted it as a spam email. those are false alarm. And the last case is true negative. True negative are the instances where the actual email is not a spam and the algorithm also predicted that email is not a spam. That means the prediction and the actual outcome matches, however both are negative. The confusion metrics allow you to see at a glance how well your model is predicting across different classes. It helps in understanding which classes are frequently confused with each other and identifies potential areas for model improvement. Now let's take a real life scenario and evaluate different performance metrics. For this example, suppose your machine learning algorithm is filtering the spam emails and it analyzed 100 emails. For your case, then the number of sample is 100. That is why we have n equal to 100. Out of the 100 emails, 50 emails were actual spam and the machine learning model predicted correctly. That means those are true positive and true positive count is 50. 10 spam emails were missed by the algorithm. Those are false negative. That is why false negative is 10. 5 good emails are marked as spam. That means these are false positive. So our false positive count is 5. And 35 emails correctly labeled as not spam. These are our true negative. That means true negative count is 35. Now let's review the accuracy matrix first. The accuracy matrix measures how often is the classifier correct. To measure the accuracy, the formula is true positive count plus true negative count over the total number of incidents. For our example, we have 50 true positive and 35 true negative, and the total count or the total email is 100. That is why 85 over 100 or 85%. That means the model's accuracy is 85%. Next, precision. Precision matrix tells when the algorithm predicts true for a spam analyzer, the true is spam email, then how often is it correct? In terms of formula, this is true positive count over true positive plus false positive. For our example, it will be 50 over 55, and that is why the value is 91%. So for our example, the precision is 91%. The next matrix is recall. Recall is also called as sensitivity or true positive rate. This represents proportion of actual positive cases that a model correctly identifies. The formula is true positive over true positive plus false negative. For our example, it will be 50 over 50 plus 10, that is 60, and the value is 0.83 or 83%. And the last is F1 score. F1 score is the harmonic mean of precision and recall. It provides a single matrix that balances both precision and recall. Since this is a harmonic mean, the precision formula is 2 times of precision into recall over precision plus recall. For our example, it will be 2 times of 0.91 into 0.83 over 0.91 plus 0.83. 0.91 is the precision and 0.83 is the recall or the sensitivity. And if we will do that calculation, it will be 86%. For our example, F1 score is 0.86 or 86%. For this certification, you should only remember the name of this matrix. You don't have to remember these formulas or how to calculate the values. AWS certification is not going to give you any formula or it will not say you to calculate the value of this matrix. You just need to remember the name of this matrix. The next is AUC-ROC curve. AUC-ROC full form is area under the curve, receiver's operating characteristic. It is also called as area under the receiver operating characteristic curve. During the certification, you can either see the abbreviated format or any one of the full form. This is also a performance matrix used to evaluate binary classification models, and area under the curve measures the model's ability to distinguish between classes, with a higher area under the curve indicating better performance. Now let's break down what is area under the curve and what is ROC. We'll start with ROC curve. ROC curve is a plot of the true positive rate or sensitivity against the false positive rate at various threshold settings. Whereas AUC is the area under the curve, and it ranges from 0 to 1, with 0.5 representing the random or just guessing. For our case, 0.5 is the dotted line. If the model is showing a 0.5 of AUC or area under the curve, that means the model is not predicting, it is just guessing. And if it is close to 1, that means the prediction is perfect. Here are some statistics. If the area under the curve value is between 0.5 to 0.6, that means your model performance is unsatisfactory. If it is between 0.7 to 0.8, it is good. If it is above 9, it is excellent. A higher area under the curve indicates a model that can better distinguish between the two classes, that is a spam versus not spam, meaning it's more likely to correctly classify a random selected positive instance higher than a negative one. Now let's review the regression evaluation metrics. Regression evaluation metrics used when your model predicts a continuous number like a house price or temperature. There are different metrics available. To start with, mean absolute error or MAE. Mean absolute error is a measure of prediction accuracy in regression task. It represents the average magnitude of error between predicted and actual values without considering their direction, whether the prediction was higher or lower than the actual values. Let's understand with an example. Imagine you are predicting the temperature for next 3 days. The actual temperatures are 15 degrees centigrade, 20 degrees centigrade and 25 degrees centigrade, whereas your model predicted as 16 degree, 18 degree and 23 degree respectively. Now, when you are calculating the mean absolute error, first step you have to calculate the errors. For day 1, the error is 1 as it is not considering the direction, that means it is high or low. For our case, day 1 error is 1 degree, day 2 error is 2 degree and day 3 error is again 2 degree. Now the next step, you have to sum the absolute errors. For our case, it is 5, and then you have to take a mean of this absolute error. Since we have 3 data points, that is why 5 over 3, which comes as 1.67. For this example, the mean absolute error is approximately 1.67 degrees Celsius. That means on an average, your model's predictions are off by 1.67 degrees Celsius. In simple terms, it tells you on average how far off your predictions are from the actual values. The next matrix is mean absolute percentage error or MAPE. Mean absolute percentage error, this is same as mean absolute error, but it shows the value in percentage term. For example, if your MAPE is 5%, it means your machine learning model's prediction are 95% accurate on an average. And why we take that percentage value? Because it is useful in comparing performance across different scales. The next is root mean square error or RMSE. And for root mean square error, we take the square of errors before averaging. And this method is useful when you should penalize for large errors more. As an example, if you want to predict the delivery times when the large errors are more harmful for your business, that time we should use RMSE to measure the model's performance. And the last in this category is R squared. R squared measures how well your model explains the variance in the target variable. If the R squared value is 1, that means the prediction is perfect. Whereas if the R square value is 0, that means your model has no predictive power. As an example, if you are predicting house prices and if your model's R squared score is 0.8, then 80% of the variability in house price is explained by your feature. As an exam tip, you don't have to remember these formulas. For this certification, just remember mean absolute error, mean absolute percentage error, and root mean squared error measures the error, that means how accurate the machine learning model is, whereas R squared measures the variance. During the certification, if you see a question asking to measure the variance, then R squared is the potential correct answer for that question. Besides technical accuracy, AWS emphasized the importance of business metrics to evaluate machine learning model in the real world. Now let's break few of them down. We'll start with user satisfaction. That means how happy are users with this model's output. As an example, if a product recommendation model may not have the best accuracy, however, user likes the recommendation, then that is the success for the model. The second, average revenue per user. Average revenue per user measures how much income is generated per user on average. As an example, if your machine learning model personalizes offer and boosts average revenue per user from $5 to $8, then it's a strong business impact. The next business metrics is conversion rate. Conversion rate is the percentage of users who take a desired action like buy a product or sign up or click a button. For machine learning model in marketing or e-commerce, this is more important, and this metric aims to improve the model's performance. The next is cross-domain performance. Cross-domain performance evaluates how well the model works across different contexts or user groups. As an example, if a voice assistant model or voice bot trained in English, it should ideally generalize well to similar tasks in Spanish or French or for other domains. And last but not least, efficiency. As the name suggests, it measures cost versus benefits. That means computational cost, time saved, or reduced manual effort by a model. As an example, if you have a machine learning model that reduces fraud investigation time by 40%, then that's a measurable gain in efficiency for your model. Now let's review some machine learning anti-patterns. That means where are the scenarios you should not use machine learning. To start with, when there is not enough data. Machine learning models learn from patterns in the data. If there is no data, that means no learning. And if you do not have data, you should not use machine learning model. The second is when the problem has fixed rule. That means if you can calculate the value with some fixed rule like calculating sales tax, then there is a clear formula and you don't need a machine learning model. Or when there is a simple program can do the job, if you can solve the problem with a simple if-else logic or a loop with some business logic, then you should program it instead of using a machine learning model. And last but not least, when it's just a straightforward probability calculation. Maybe you want to calculate the probability of flipping a coin or rolling a dice, and the outcomes are well defined and which can be calculated with probability formulas. In those cases, you don't need machine learning model to estimate something which is already available or which you know precisely. During the certification, if you see any of these use cases, you should not choose any machine learning model or you should not choose any machine learning algorithm. For those scenarios, you should choose a solution which is getting solved using AWS Lambda or Amazon EC2 or EKS or ECS with a rule-based workflows. On the other hand, you should only use machine learning for the scenarios where you need predictions or a pattern discovery. Please stay tuned and explore other modules from the Bootcamp playlist for a comprehensive understanding of the topics required for the certification. That wraps up this module. If you found this video helpful, please give it a thumbs up, subscribe for more update, and feel free to drop any question or feedback in the comments. We would love to hear from you. I hope this session helped you gain a deeper understanding and brought you one step closer to your learning goals. Thank you very much for watching and learning with us at Cloud Expert Solution. See you in the next module.